Well, hi there, everyone. We just finished up a unit on the theory of trigonometry, and you're going to find out that our next endeavor is to look at the triangles of trigonometry. It's possible that you're going to feel that you've had some exposure to this, but as I mentioned earlier, my goal this year is that you can go a little deeper, and even better that you understand more the why behind all the things that we're doing. So let's go back. Let's go back one more time to a little bit of the theory of trigonometry. Here's a problem that sometimes I'll tell kids, you probably don't need to write this down. Honestly, just watch, because I bet you just got this right. I hope you just got this right on the test that you just took. But it's a very, it's a great segue into our triangle unit. So what do we got? A point and a terminal side, right? We got a point and a terminal side. So as you've gotten good at, you can make a sketch, and sometimes we call it the sketch, where we clearly have a point and a terminal side that makes an angle, that makes a triangle. And what can we do next with this triangle? Well, of course, we can start to label it. We can find its dimensions, which come from the point, and then a little bit of thinking will give us that hypotenuse. And what do we do with this? Well, we find trig values. Trig values are like the sine and cosine and tangent of theta, and of course those come from those definitions that involve x, y, and r. Well, you should be saying, yes, I know this. Can you show me something new? Well, yeah. Watch carefully. The x and y axis just disappeared. Now, if you missed it, the question here really is, what if the x and y axis disappears? Will the sine of theta still be 9 over 15? Will the cosine be 12 over 15 and tangent be 9 over 12? Well, the answer is yes, because they are actually all based on their relationship to theta. Now, if they're based on their relationship to theta and we no longer have the x and y axis, then maybe we need some new words. We need some new words to describe the sides of this triangle. How about this side? You know, the side that we were calling R, but you already knew that that side was called the hypotenuse. Let's call it the hypotenuse, since we don't really have a radius anymore. How about this side? This side that is across from the angle. The side that is opposite that angle. Have you heard these words before? Opposite, hypotenuse. We've only got one word left, or one side left. We need to come up with a word for this side that is beside the angle. It's beside the angle. We have a fancy word. When you're beside something, you are adjacent. And so we can describe the sides of this triangle based on their relationship to theta. Now, does that change our definitions? Well, it doesn't change them, but it kind of enhances them. In other words, now that we have these words, instead of using, say, y over x to describe the sine of theta, we can describe it with an opposite over a hypotenuse. So the sine of theta is opposite over hypotenuse. Now, it's still the ratio of those numbers, but now we have some words. How about cosine and tangent? Now, these definitions, I think we can call them, they would be a great thing to now jot down. If you haven't written anything down yet, you may want to start with the definition of sine being opposite over hypotenuse, cosine being adjacent over hypotenuse, and tangent being opposite over adjacent. Now, what we're going to do is we're going to use these sort of new, although I know some of you are saying, I've heard this before, but we're going to use these new definitions to help us solve a right triangle. Now, solving a right triangle means that we're going to find all the sides and all three angles. We're going to find all the dimensions of the right triangle. And I still find that students, even though perhaps they have seen some of this before, still can use a little bit of a refresher on the words. And so here's a simple sketch of a triangle. It's not a flag, it's a triangle. It's got a right angle, and of course the side that is across from that right angle, well, yes, that's always the hypotenuse. That's kind of the freebie, but it's the other two sides that we want to be very careful that we realize that the one that is across from the angle, now that's the side that's going to be the opposite. But it's the side that is beside the angle, the side that's beside the angle, that's going to be the adjacent. So it's always based on its relationship to theta. Okay? Let's use these words to solve our first right triangle. Basically, I'm going to, and you'll be given, this is kind of the way these problems work, you'll be given a sketch of a right triangle. Probably given some. Let's label let's label the vertices of the triangle. Very common from geometry to label them with capital letters. So we've got the vertices as capital A, B, and C. Now that would also relate to the angles. Not often, but the angles match with those capital letters. Let's say that I give you 49 degrees is equal to angle A. The sides of the triangle. Now the sides always relate to the angles. In other words, if big A is right here, then lowercase a, side A, is going to be across from it. So let's say that I tell you that side A is 7, and we don't know side B or side C, but we do know their location because they are, again, they are opposite of each of those angles. Now, if we want to solve this right triangle, we're going to use our definitions of sine, cosine, and tangent. But what we're really going to need is we're going to need some words. Okay, and it's up to you if you want to write this. I encourage you to still write it until you don't need to anymore. Certainly, side C is the hypotenuse. Again, that's kind of a freebie. But because the angle 49 is given here, then this side A will have to be our opposite side. And this side B is going to be our adjacent side. So I still think it's a good idea to label your sides to make sure you have these words straight, so that now we can start to pick a trig function. Now, what do I mean pick a trig function? Well, I'm talking about picking either sine, cosine, or tangent. And you always want to make sure you pick a trig function that uses a side that you know and a side that you want to know. A side that I know and a side that I want to know. Well, there's only one choice for a side that I know. The side that I know is the opposite side. So I definitely are going to have to pick a trig function that uses the word opposite. And what side would you like to know? Would you like to know side B? Great. Would you like to know side C? That's fine too. The truth is we're going to need to find both. But for the purpose of this problem, why don't we just find side B? At least why don't we start by finding side B? Now, to find side B, I need to pick a trig function that uses opposite, because that's what I know, and adjacent, because that's what I want to know. Opposite and adjacent. Opposite and adjacent. Tangent, right? We're going to use tangent because tangent is opposite over adjacent. Now, when you use tangent, you actually start filling in what it is that you're given. And so 49 degrees would make perfect sense to be filled in for theta. And the opposite, being the number 7, of course, is what I know, but the adjacent, that's what I want to know. I'm going to put the letter B there because it actually is side B. I mean, you could put the letter X, but most students will pick the letter of what you're trying to find. Now, this guy right here, this is an algebra equation, and we want to solve it. And we want to solve it for B, so we're going to have to multiply both sides by B. Now, after you multiply both sides by B, you want to divide both sides by the tangent. And what's going to end up happening is we're going to take 7 divided by tangent of 49. Now you want to make sure you can do this on your calculator, so I encourage you to get out your calculator. 7 divided by the tangent of 49. Okay, the calculators that you guys own, you're going to want to make sure that they're in the right mode. So remember that you will want to switch that to degree mode. For some reason, you can't really see that on my screen very well, but this was the word degree, so make sure you switch it to degree mode. And then we're going to want to do 7 divided by the tangent of 49. Okay, you can just kind of do that in one little step. And we'll round our answer to 2 decimal places. So we're going to get 6.09. Okay, now again, make sure you do that on your calculator. And we are on our way to solving this right triangle. I feel like there's another side that we need to find. Remember, it was side C. Now, the one thing that's true is that since we found side B to be 609, and we have side A already to be 7, then finding side C could be found using multiple methods. Could you use the Pythagorean theorem? Yes, you could use the Pythagorean theorem. It's not really that hard, and it uses a basic, of course, equation. The one thing, though, that it does do is it uses a rounded number. And if I use a rounded number, then my answer is already that much more rounded. Again, it is not wrong. In fact, you will have to do this for some problems. But I would like to use a trig function just to kind of encourage you guys to be thinking about what we know. Now remember, we know the opposite. We still know it. And now we want to know the hypotenuse. Opposite and hypotenuse. Survey says sine, right? Sine of theta. Because that, by definition, is opposite over hypotenuse. Now when I use the sine of theta, it'll still be the sine of 49. The opposite was given, and the hypotenuse is my unknown. So I find myself in a very similar situation. Solving this simple little equation is just 7 divided by the sine of 49. Make sure you can do that on your calculator. The cool thing about this is that it comes out, you might say, a little bit more exact, and now I can round it to 2 decimal places. But 9.28 is still very, very close to the value we would have gotten even with Pythagorean theorem. Now, we're not done with the problem because, remember, we're trying to solve the entire right triangle. Well, there's only one more thing left to do. It's to find this missing angle B. And it's almost a freebie, but you have to make sure that you still do it. Remember, all your angles add up to 180, or you can just subtract your 49 degrees from 90. But either way, we want to find the rest of that angle, the rest of our triangle, and now we are solved. Now, when you're solving a triangle, you want to pick the right trig function. It's got to use something you know and something you want to know. What about this example, which maybe feels like that there is more that we want to know. Okay, now what I'm doing here is pretty clear, sketching triangle ABC, but only giving you guys side A and side C. In other words, no angles, except for the right angle, of course, but no base angles. Now, what we want to realize here is that that is our first objective, is to find one of these angles. Now, the truth is I could find angle A if I feel like I'm a type A person, or I could find angle B if I feel like I'm a type B person. In other words, I can find either one that I want. Just to switch things up a little bit, let's be a type B person. Let's say that angle B is my angle of focus. Now I say, what do you mean angle of focus? Well, remember how the sides are always described based off of the angle. So that means that side A is actually my adjacent side. Now this is still the hypotenuse over here, side C, but side A is my adjacent side because it's adjacent to angle B, which again is the angle that I am focusing on. Now, when I'm looking for an angle, I have to switch my thinking a little bit from using a side that I know and want to know to be using side that I know and know. If you look at this sketch, you should agree that there's really no other choice but to use the two sides that I know. So, I need a trig function that uses adjacent and hypotenuse. Does anybody know a trig function that uses adjacent and hypotenuse? That's correct, it's cosine, because cosine is adjacent over hypotenuse. Now, I should have labeled this find angle B, just to give it a little bit more organization. So we're going to find angle B, we're going to use cosine, and when you use it, you start to fill in. You fill in what you know and what you know. Of course, 21 is the adjacent, 30 is the hypotenuse. I don't know angle B, so most people are going to put a capital B there. Makes sense with that equation. Solving this equation. Now, this is different than what we did in the previous example because we're solving for an angle. Solving for an angle. Well, you're going to learn that it doesn't make sense to divide. You can't divide by cosine. Sorry, it doesn't work that way, especially because what the heck are you going to do over here? But we do need to do the opposite. It's called the inverse. It's the inverse cosine. And that does cancel with my cosine, leaving us with just angle B, but also leaving us with something we have to figure out on our calculator. Now again, this is called the inverse cosine. And on your calculator, there's an inverse button. It would be, for most of you, a shift or second, and then you can hit your cosine button. Again, if you look down here, you're going to tap second, and then your cosine, and you'll do the inverse cosine of 21 over 30. Now look, it comes out to be an angle. I mean, it even kind of looks like an angle. 45.57 degrees. Yeah. So the inverse gives us an angle. Now, the reason I keep saying that is because that is a key idea. What is the key idea? You're always going to use an inverse when you're looking for an angle. Or again, an inverse will give you an angle. Now remember, we want to solve the entire triangle, and that would mean finding all the sides and angles. Where did I go? Too far? What? There we are. That would mean we want to find all the sides and angles. So what do I got here? I got angle B to be 45. You don't necessarily have to recopy it, but that should make it a little more clear that the other angle down here, angle A, of course, is just the rest of the 180 degrees. Are you allowed to subtract? You are. You may subtract. It's the easiest way to find 44 degrees. We still have to find side B. Side B is going to be this lowercase b over here. Pythagorean theorem? Sure. Especially if you notice that you're not using any rounded numbers. So what else would you choose? I mean, this would be the easiest route to solve for side B. Now, we have two situations. Finish up that side B there. We have two situations that we did. Okay, One of them was finding a side, and when you find a side, you want to make sure you pick the right trig function. It's going to have to involve what you know and what you want to know. And then the other situation is if we are trying to find an angle. And if you're finding an angle, you're going to have to pick what you know and what you know. If you're ready, and I would imagine that you are, but if you don't feel like you need to see any more examples, then I'm going to kind of say, hey, why don't you get started with the homework? Okay, it's 6 problems where you're basically solving the triangle, finding all the sides and angles. If you feel like that you need another example, since I'm not here to do that with you, you can always do a quick search. You can talk to your neighbor, or I might even say, why don't you still try the first problem and see if you understand it a little better than you might think. Try the first problem in the homework, and then skip to number 6, because that will cause you to do a problem that's a little bit backwards using an inverse. So it'll give you a chance to kind of use this homework as a chance to try 2 examples, and then we will pick it up from there next time we're together. Well, hi there.